Hi friends, welcome to my channel. So in last lecture we have discussed about the classification of the instruments like absolute and secondary type instrument we have seen, okay? And in secondary type instrument there are three types mainly: indicating instruments, integrating instruments and recording instruments. And then our next topic is null type and deflection type of instruments. So what is null type? So in null type instrument there are many range, means 0 to null indication was there, and sliding contact are also there, and galvanometer is connected in series with the battery. So if reading take place, then galvanometer at balance condition, galvanometer indicate the null detector, means 0 in the value, okay? So an instrument in which 0 null indication determines the magnitude of measured quantity, then it's called the null type of instruments. Here basic figure of the null type instrument. So finally, in null type of instrument, the method of comparison between the measurand and the standard result in to obtaining a null or 0 indication, which determines the magnitude of the measurement. So in that kinds of instruments, the basic method is to compare between measured value and the standard value, and then notice the balance condition, okay? So example of that kinds of instrument is potentiometer in the galvanometer. You have seen the potentiometer, okay? So what is potentiometer? Potentiometer is nothing but the instrument which is that kinds of instrument, okay? Null type means there are also galvanometer and sliding wire, and at balance condition galvanometer reads 0, okay? And you can also see in the bridge circuit. In later chapter we have also discussed the bridge in resistance measurement chapter, okay? There are many bridges like Kelvin double bridge, Wheatstone bridge, AC bridge, DC bridge, okay? So there I also discussed. Another type of instrument is deflection type instrument. So that is mainly used, and you have ever seen that kinds of instrument in laboratory of our subject, okay? So what is deflection type? So in deflection type instruments, the deflecting torque moves the pointer moving system on the calibrated scale. Means in that kinds of instrument the moving pointer was also there, and if we measure the value, according to measuring value, pointer deflects on the scale, and pointer reads on the display, okay? So in the instrument in which the measured quantity produces a physical effect which deflects or displaces the moving system of the instrument, and that kinds of instrument is called as deflection type. Other word, the instrument in which the deflection provides the basis for measuring the electrical quantity, okay? Such type of instrument is used for measure under dynamic condition. So example of that kinds of instrument is analog ammeter, voltmeter, okay? You have ever seen in a laboratory to measure the current, okay? So there are nothing but the N and S pole, okay? So in this instrument N magnetic field is produced due to N and S pole, and in between that spring was also provided, and with the spring pointer wheel attached, okay? So there are deflecting torque is clockwise direction, and controlling torque is opposite to the deflection torque, because the deflection torque, due to deflection torque, pointer moves to the scale, okay? So there are many oscillation and not stable at all because of change in the measured quantity. So controlling torque also provide to uh, smooth the pointer on the scale. Okay, and example of that kinds of instrument is PMMC, means permanent magnet moving coil instrument, dynamometer type moving iron instrument. Okay, so that all are instruments we will discuss in later chapter. Okay, and after that there are another type of instrument, means analog and digital type instrument. I hope you are familiar with that topics. Analog, what is analog instrument? The signal which continuously vary and take infinite values for a given range are called the analog instruments. Okay, the analog instrument is defined as the instrument whose output is continuous function of time. Okay, and vary with the time. So in a analog system the function continuously varies. Okay, the example of that kinds of instruments are PMMC type, permanent magnet moving coil type voltmeter, null deflection instruments like DC potentiometer, Wheatstone meter bridge. Okay, so that are classified in analog instruments. So what is digital instruments? So the signal which vary in discrete steps. Okay, in digital instrument the function is not varying with continuous time but discrete step value. Okay, and take finite different values in the given range are called the digital instrument. Okay, and there are also measured value is in the form of digital number. Digital number is indicated on the digital scale. Okay, and it works on the principle of quantization, and quantization is the process of converting the continuous input signal into the countable output signal. An example of that kinds of instruments are logic analyzer, microprocessor based instruments, computer, digital counters. That are also examples of the digital instrument. Okay, and next topic is advantage of the digital instrument over analog instruments. Okay, there are various advantage of the digital instruments. So the output of digital instrument is in the digital form. So output can be given to flip-flop disk computers, printers for storage and future expansion. So future expansion is easily possible in the digital instruments. Okay, and in this limit can be and accuracy was also high in. So the readings are also in binary system, so error will be minimized using the digital instruments, and resolution of the resolution is very high for the digital instruments, and an error should be reduced in using the digital instruments. And the comparison, if compare with analog and digital, then signal of the analog instrument is continuous signal. Okay, and digital discrete signal. Data transmission is subjected to the noise by the noise, and noise immune it without deterioration in the digitally. If we discuss about the memory, then analog instruments stored in the form of wave signal, and the digital is stored in the form of binary bit, means 0 1. Okay, power analog instrument is draws the large power consumption is more in the analog instruments, and digital instruments is low and negligible power. The impedance of analog is low impedance, but in digital larger. Errors is more in the analog instruments. Cost is analog instrument is cheap, but digital instruments is costlier. Resolution is good in digital instruments, analog instruments less resolution. So here the classification of instruments are over. If you any query, then contact me. Next topic is characteristic of the instruments and measuring system, measurement system. So what kinds of characteristic? So the performance characteristic of instruments mainly divided into two parts, means static characteristic and dynamic characteristics. So in static characteristic, what is? So the static characteristic of instrument are required to be considered for the instruments which measure unvarying process conditions. Okay, the static characteristics are defined for the instruments which measure quantities which do not vary with time. So the set of criteria defined for the instrument which are used to measure the quantities which are slowly varying with time or mostly constant. Okay, so that is do not vary with time is called static characteristic. Means static characteristic is not varying with the time. So that are the various static characteristic of the instruments. Desirable and undesirable. In desirable static characteristic there are accuracy, precision, sensitivity, reproducibility, static error and resolution. And undesirable static characteristics are drift, dynamic error, dead zone and hysteresis. So we will discuss one by one characteristic, then that are very important topic for your with your examination. So we will discuss that all the characteristic in next video lecture. Okay, if you any query or any doubt, then contact me. Thank you.